Hi, my name is Bob Pryor, and I'm talking to you today about trigonometry in the XY plane. And certainly one important thing to know is that every point in the XY plane is on a circle. Let's take, for example, the point 2, 4. It's a first quadrant value. Here it is in the XY plane. And it's on a circle. I've already drawn the circle for you, and there, of course, is the radius. And we see the radius value of 2 radical 5. And if we didn't know how to get that square root of 2 square root of 5, we use our equation of a circle, the one that's centered at the origin. And we use the values 2, 4, 2 for x and 4 for y. And that's how we calculate what the radius is. And we see here 20 is equal to r squared. And you can follow through r equals 2 radical 5. So at that point, 2, 4, it's on the very particular circle. X squared plus y squared equals r squared. And in this case, r squared is 20. So that's the equation of that particular circle. Let's now take a look at any point in the XY plane. It's going to have a given radius to the origin. And for example, here's one in quadrant 1. And in the XY plane, we have a radius and we have theta. And theta is an acute angle. And there's not much to that. That's kind of standard. However, in quadrant 2, we have the XY and it's still got a radius. But notice that theta extends all the way from the positive x-axis. And that's true even in quadrant 4. The angle theta extends all the way from the positive x-axis. That's a reflex angle. So we saw acute, obtuse, and now reflex. So now, how does that affect the new definitions of sine, cosine, and tangent? When we look in the first quadrant, we see that we've got the ordered pair xy. And if we lay it out and draw a rectangle by dropping to the x-axis, straight on down to the x-axis, form a rectangle. Of course, the radius is there, and this forms a triangle. X and y are the sides, and r is the hypotenuse. So what we're looking at is a right triangle, and we can use our right triangle trigonometry, SOHCAHTOA. And we see right there the sine of theta is opposite over hypotenuse, y over r. Cosine of theta is adjacent over hypotenuse, x over r. And the tangent of theta is the opposite over the adjacent, y over x. Note that r is found on r squared equals x squared plus y squared. And r is always positive. But take a look in quadrants 1, 2, 3, and 4, x and y, sometimes positive, sometimes negative. And we must take that into account. R, again, no matter what quadrant theta is in, r will always be positive. So let's look here at example A. We're going to find the sine, cosine, and tangent of theta if the point -4, 2 radical 5 is on the terminal side of theta. That's where the angle theta ends. Remember, it always starts at the positive x-axis, but it will end somewhere in one of the quadrants. And in this particular case, it ends at the point -4, 2 radical 5. The x value, of course, -4, and the y value is 2 square root of 5. And that, of course, is a quadrant 2 value, where x is negative, y is positive. We'll just guess as to where x is about -4. The value of 2 radical 5 actually is more than 4, and it's positive. So we see that located, we see those on the x and y axes, and of course there's the point, -4, 2 radical 5. Again, there is a radius associated with that. Even though we're not drawing the whole circle, we still have a radius there. That's the value of r that we're going to find in just a moment. And there's the angle theta. Comes on around from the positive x-axis, always from the positive x-axis. And I'm going to do something real fast here to show you the development of the value of r. based on our point x, y, -4, comma, 2 radical 5. And so there we have the value of x and the value of y and a new value of r, which is 6. And we can use these to now find, in this particular, for this particular point, the sine of the angle theta. Sine, of course, always y over r. And that is 2 radical 5 over 6, which simplifies to square root of 5 over 3. And we have the cosine of theta. We just learned that cosine of theta is x over r. And in that case, that's -4 over 6. And that simplifies to -2/3. And the tangent of theta. We've seen just very recently that that is y over x. And the y value is 2 root 5. And the x value is -4. So when this simplifies, we actually get a negative fraction, negative radical 5 over 2. You must memorize these relationships. This new sine is y over r, cosine y, x over r, and tangent y over x. So let's put another angle in the quadrant 2. There's the point -3, 1, and I'm drawing that radius. And again, we can form a right triangle, but notice that the value of theta is actually an obtuse angle because it comes from the positive x-axis. And yet we can see here this right triangle in quadrant 2. It's actually on the negative x-axis. We draw to the x-axis, in this case the negative x-axis. And we can still talk about the value of theta, but at the same time we've got this acute angle inside. I think you can see that there. Let me just redraw it for you. It's called theta hat. This angle inside, this acute angle. And it's got theta with a little hat on it. So let's just see what theta hat is. As a reminder, it's an acute angle, and it will always be positive as an acute angle. And we always draw that triangle to the x-axis as one of its sides. Might be the positive x-axis, might be the negative x-axis. And the other side of the triangle, which forms the radius, is the one that extends to the origin. And that's to help create the angle. So theta hat is found only when making a right triangle with the x-axis, never the y-axis, even in quadrants 3 and 4. It's always to the x-axis. So let's take a look at example B here. It says, for each, locate theta on the circle and identify theta hat. And that means that we're going to find the nearest x-axis and how many degrees it is away from the nearest x-axis. So here, A is theta equal 160 degrees. We know that's very close to 180. Pretend that's a straight line. Like I said, very close to 180 degrees. And so theta comes around from the positive x-axis, but we're going to compare this for theta hat to the negative x-axis at 180 degrees. And we can see that that's a difference of 20 degrees, so theta hat is 20 degrees. Or if we don't see it outright, we can just go ahead and do some subtraction. That's certainly allowed. Let's take a look at example B. Here, theta is 335 degrees. That is in quadrant 4, and it's very close to 315 degrees. So it's 335 is more than 315. What we want to compare it to, though, is the x-axis. And in this case, that means the 360 degree mark. And you might be able to just see that that is distance of 25 degrees, or you can do some subtraction, which we're going to show right now. So there's theta hat, 25 degrees. Let's look at example C. 410 degrees. So we here have an angle that's more than 360, which of course when we draw it goes beyond the 360 degrees. And it's a little bit beyond the 45 mark, it looks like. So we're going to compare it to the nearest x-axis, that's 360 degrees. A little subtraction, or you can just figure that out in your head. Its theta hat is 50 degrees. And example D. Here we have a negative angle. Well, it works in the same way. Negative 140 is close to negative 135 degrees, a little bit beyond. Of course, coming in the negative direction. Its nearest x-axis angle is negative 180 degrees. So now we're comparing negative 140 to negative 180. And I think you can see that there's a 40-degree difference. Remember, though, theta hat is always acute, it's always positive, so actually theta hat is 40 degrees. And the positive there, I just put that there for emphasis. All right. So what about trigonometric values for axial points? Let me go ahead and just put some arbitrary points on the axes, positive and negative, x and y axes. And I'll just call the first one 4, 0, and then the y-axis 0, 5. I'm just picking some numbers here. Negative 1, 0, and 0, negative 2. Each of these points, just like any other point, is on a circle. Of course, we see the angle measures around those axes, but even this point 4, 0 is on a circle. It's got a nice radius of 4. It's 4 away from the origin. And at 90 degrees, the point 0.5, the radius there is 5. And at 180 degrees, the radius for that point, the r value, is equal to 1 because it's a distance of 1 from the origin. The actual values are kind of nice that way. And at the 270 degree mark, the point 0, negative 2 is a distance of 2 away from the origin, so the radius is 2. We don't really have to use that formula x squared plus y squared equals r squared in this case. So let's take a look at the sine of 270 degrees. Sine, as we've seen recently, is y over r. You've memorized that, I hope. And so we get negative 2, is the y value, over the radius of 2, and that simplifies simply to negative 1. For cosine of 0 degrees, it's the x coordinate over r, and the x value is 4 divided by the r value, also 4, it equals 1. Cosine of 0 degrees equals 1. At 90 degrees, the tangent, being y over x, is 5 over 0. This is, of course, undefined. I'm not going to do cotangent of 180 degrees right now. Okay, so in the quadrants, not talking about axial points right now, but in the quadrants, we have positivity and negativity based on the location, and we use these letters A, S, T, C, A being all, S for sine, T for tangent, and C for cosine. And it all depends on the x and y values, positive and negative of x and y values in the different quadrants. So when to say that they're all positive in quadrant 1, that means sine, cosine, tangent. They are all positive. But in quadrant 2, to say that the sine is the only positive one and the others are negative, and the t means the tangent in quadrant 3 is the only one that's positive. In quadrant 4, only the cosine is positive. Notice in quadrant 2 that sine is positive, and that means it's reciprocal. Cosecant is also positive. Likewise, in quadrant 3, tangent and its reciprocal cotangent are both positive. Likewise, in quadrant 4, cosine and its reciprocal secant are both positive. So let's put that into play now. In example D, it says, based on the given information, in which quadrant does theta terminate? So notice there's greater than 0, which means positive, and less than 0 means negative. And let's keep in mind the A, S, T, C. So first of all, cotangent theta is positive. That occurs in quadrants 1 and 3. And sine being negative occurs in quadrants 3, and 4. So the question is, where do they combine? And that has to be quadrant 3. That's where both are true, that cotangent is positive and sine is negative. Next example. Here the cosine is positive, cosecant is negative. Now, cosine is positive in quadrant 1 and quadrant 4. Cosecant, like the sine, is negative in quadrants 3 and 4. And so what they have in common is quadrant 4. That's where cosine is positive and cosecant is negative. Let's look at example C. Tangent is negative. That's quadrants 2 and 4. Secant is also negative. That's quadrants 2 and 3. So they are combined in quadrant 2. So that's where tangent is negative and secant is negative. It's quadrant 2. Example D. Cosecant is positive. That's like sine being positive. And that's in quadrants 1 and 2. And cotangent is positive. That's like tangent being positive in quadrants 1 and 3. So they are together positive in quadrant 1, where cosecant is positive and cotangent is positive. Let's use that information in example E here. We're going to be looking at 45-degree angles. So I'm going to start, first of all, with a 45-degree angle, which of course is in quadrant 1. And that is a line in which both the x and y are the same value. So we could pick a point such as 4, 4. In quadrant 2, the 45-degree angle measure is at really 135 degrees. And in this case, the x and y are the same except one, well, they're opposites really. Let's pick a point here on that line, and we'll make the x negative 5 and the y positive 5. And in quadrant 3, the angle measure that's a 45-degree equivalent is 225 degrees. And in this quadrant, both the x and y are negative. So let's choose, let's do -3 and -3. Now, let's go back to quadrant 1 for a moment with the 45-degree angle, which really forms a 45-45-90 triangle. And the x and y values are the side measures. Those are 4. We know the hypotenuse is 4 times square root of 2. And so that means that radius that we have right there for that 0.44, the radius is 4 times square root of 2. In quadrant 2, it's the same thing. It's got a 45-degree angle, and the radius is 5 radical 2. And in quadrant 3, it is a radius of 3 radical 2. So we have the x and y values, and we have the radius for each of these. So sine of 45 in quadrant 1, the y over r is 4 over 4 radical 2. And when we simplify that to 1 over radical 2, and of course we must rationalize the denominator, because I said so, square root of 2 over 2. In quadrant 2 at 135 degrees, cosine is x over r, which is -5 over the 5 radical 2. And we divide out the 5s, we get -1 over radical 2, and rationalize, we get -√2 over 2. So the cosine is negative in quadrant 2, and that makes sense. Only sine is positive in quadrant 2. And in quadrant 3, tangent being y over x, -3 over -3, which is a +1, and that makes sense because tangent is positive in quadrant 3. Okay, so here's the toughest one of all. Theta terminates in quadrant 4. That gives us a piece of information right away. That means that we're dealing with a point where x is positive and y is negative. We're also told that the cotangent of theta is a very specific value, -√5 over 2. To understand that better, it's actually better if we can turn this into tangent and say tangent of theta is 2 over negative radical 5, or recognize that in quadrant 4 it's a -2 over square root of 5. Of course, being tangent, it's y over x. And in quadrant 4, the y value is the negative. So we'll rewrite that as negative 2 over positive square root of 5. But that gives us our y and our x value. Let's put them down, and then we need to just simply solve for r at that point. So again, the y value, negative 2, the x value, square root of 5. So let's go ahead and solve for r using r squared equals x squared plus y squared. And here it is done quickly for you. And we see that r is equal to 3. So we have those three values. We have the y value, the x value, and the r value. And that's going to help us find sine, cosine, and tangent of theta. So the sine of theta, I always write it down, y over r, is negative 2 over 3. And that doesn't simplify, negative 2/3. Good answer. Cosine of theta, x over r. Hope you're getting used to these new definitions. And in this case, that's radical 5 over 3. And the tangent of theta is y over x. And in this case, that is negative 2 over square root of 5. And what we get from that is we will rationalize this time and get negative 2 radical 5 over 5. All right. Go ahead, rewind, stop, pause, do whatever you need to do if you need to go back and look at something. I hope this has been helpful to you.